This is Miss Humbert here. Today we're going to be doing Unit 4 Notes 3, so we're going to be talking about rectangles. So this is a continuation of our polygon unit that we started last trimester. So today we're going to talk about just different properties that we can use when talking about rectangles. So first of all, a rectangle is a parallelogram. Well, let's remember what a parallelogram is. Remember, in a parallelogram, all the sides are parallel. So the two opposite sides are congruent to each other. Also, their angles that are opposite are congruent to each other. Well, a rectangle is a parallelogram with 4 right angles. And I'm going to write it up here so that I can write it out big. So 4 right angles. Since the rectangle is a parallelogram, then a rectangle also has the following properties. So opposite sides are parallel and congruent. Opposite angles are also congruent. And consecutive angles are going to be supplementary. Remember that supplementary means that they add up to 180. Diagonals also bisect each other, so that means that they cut into 2 equal pieces when they bisect. So that right there is kind of some of the starting properties for a rectangle. Let's continue. In addition, the diagonals are always congruent. So not only do they bisect each other, meaning these halves are the same, but we're also saying now that this line and this line are congruent to each other. So it's not even just the 2 halves of one diagonal bisecting each other. The entire diagonal in and of itself is congruent. So let's take a look at number 1. A rectangular park has 2 walking paths as shown. If PS is 180 meters, so let's go ahead and look at that. PS is 180 meters. PR, this diagonal, is going to be 200 meters. Find QT. So QT is this thing right here. Well, remember what we learned. We learned that the diagonals are the same length. Okay, so that means that if this guy right here is 200, that means this whole thing is 200. We also talked about how they bisect each other. So that means this half is the same as this half. So if this whole thing is going to be 200, then QT is just going to be half of that. So then QT is just going to be 100 meters. Next, let's take a look at TS. So taking a look at TS, so TS, this guy right here, is 120 meters. And then it wants us to find all of PR. Well, remember, PR is going to be congruent to QS. Well, if TS is 120, then QT is also 120. So the whole length of it is going to be 120 plus 120. And again, PR is going to be congruent to that. So you add those two together and you get 240 meters. Okay, so PR is going to be 240 meters. All right, let's take a look at number 2. Quadrilateral JKLM is a rectangle. If the measure of angle KJL, this guy right here, is 2x plus 4. Sorry about the announcement there, guys.
Please come to the second floor office. Brad Gallen, please come to the second floor office.
Then here, JLK is 7x plus 5. Well, here's what I know. This angle has to be congruent to this angle here. Remember, these 2 lines are parallel. So this angle and this angle are alternate interior angles. So this guy down here also has to be 2x plus 4. Well, these 2 angles have to form a right angle because it's 90 degrees in the corner. So then we're going to have 2x plus 4 and 7x plus 5, and that has to be equal to 90 degrees. So now we want to add up our x's. So 2x plus 7x is 9x. 4 plus 5 is 9, and that's equal to 90. So then we're going to subtract 9 from both sides. 9x is equal to 81. Divide both sides by 9, and you get that x is equal to 9. Okay, so that's your answer for number 2. Let's move ahead and take a look at number 3. Now, you're going to have to do something really similar to this on your homework, so I think it's really important that you pay attention. So we want to figure out if it is a rectangle. So basically, we want two sides to be equal, two opposite sides to be equal, and we also want the diagonals to be equal. So we just need to go and calculate a bunch of lengths of the distance. So when we calculate out PQ, maybe write this down on your note sheet. Get that distance formula written down. X2 minus X1 quantity squared plus y2 minus y1 quantity squared. So now I want to go ahead and I want to find PQ. So I'm just going to go through and follow the steps. So I'm going to do x2 minus x1. Remember, when you subtract a negative, it becomes plus a positive. y2 minus y1. So then here we're going to get 6 squared plus a negative 4 squared. So then we're going to get 36 plus 16, and that's going to give us the square root of 52. Well, when you take the square root of 52, you get 7.21. So 7.21 is your first side. Let's take a look at our second side, RS. So we're just going to calculate out those points. So you're going to have to look at them on your note sheet since I had to scroll down. So we're going to do x2 minus x1 is going to become plus the positive, and then y2 minus y1. So then here we get negative 6 squared plus 4 squared. That's going to give us, oops, this should be squared, 36 plus 16, square root of 52 again, which again was 7.21. So then, the length of RS is 7.21. Let's take a look at PS now, so calculating out that line. So taking a look at PS, we're going to do y2 minus y1, that's going to become x2 minus x1, and then y2 minus y1. Well, that first parenthesis is going to become negative 2 squared, and then that second parenthesis, negative 3 squared. Well, negative 2 squared is 4, negative 3 squared is 9. So then we're going to get the square root of 13. And the square root of 13 is 3.60. So then for PS, 3.60. Let's take a look at QR to start off with. Next, so we're going to do QR. So again, we're going to do x2 minus x1, that's going to become plus a positive, plus y2 minus y1. So then here you're going to get a negative 3 squared plus a negative 2 squared. And then we're going to get 9 plus 4, which is the square root of 13, and that's going to give you 3.60. So QR is 3.60. So far, so good. We have two congruent sides. So then we just need to check that our diagonals are congruent. So now I'm going to calculate the distance between P and R. So to calculate the distance between P and R, x2 minus x1, that's going to become plus the positive, y2 minus y1. So then here we're going to get 4 squared plus a negative 7 squared, and that's going to give us the square root of 16 plus 49, and that's going to be equal to the square root of 65. Well, the square root of 65 is 8.06. So that's your answer for PR, 8.06. Let's take a look, last but not least, at QS. So taking a look at QS, negative 7 minus 1 quantity squared plus 0 minus a negative 1, that's going to become plus a positive. And then here we're going to get a negative 8 squared plus 1 squared. And then you get the square root of 65 plus 1. 64 plus 1, which is the square root of 65, which is 8.06. So again, we're going to go up here, and we get 8.06. So our diagonals are congruent. So yes, this guy right here is a rectangle. So let's take a look at that last problem, which is using the Pythagorean theorem. So right in here, because that's a right angle, I actually have a right triangle. So XW is 3, WZ is 4. So I actually have two right angles. So once I can figure out this line, I'll know the hypotenuse of both. So let's pull that right angle out. So we have 3, and we have 4, and we have x. So we have x, our two legs squared using that Pythagorean theorem need to be equal to our hypotenuse. Well, 3 squared is 9, 4 squared is 16, and that's equal to x squared. So then I get that x squared is equal to 25. So now to completely solve for x, I need to take the square root of both sides, and I get that x is equal to 5. So here I get that x is equal to 5, which is going to be my answer for both of those problems. So that concludes your note video today. Go ahead and show me your completed note sheet when you're done, and I will give you the homework sheet. Thanks for listening.